We are going to talk about the arc length again, and then also how to change our degree for a certain portion of our circle into a radian measure. So first off, let's review from our arc length from before that we always need to take the degrees of our circle that it takes up times 3, or divided by 360 degrees, and that's a portion of the circumference. So that's where this 2 pi r comes from, is the circumference of our circle. All right, so if we are finding the arc length of A to B, so the actual length around this edge of the circle, we need to take the degrees, so that'd be 60, divided by 360 degrees, times 2 pi r. So our radius is our 9, and now we can multiply it. So since we've done this before, I want you to go ahead and multiply this together and tell me what your answer is in terms of pi. So you could have put it over 1, and if you multiply all of the top part together, so all of our numbers, so 60 times 2 times 9, you get 1080, and then we still have pi at the end of it. Then that is all over 360, so then you should have divided just the number portion, and we get 3 pi. So that's what it is in terms of pi. If you wanted the approximate answer, that would be 9.4 centimeters. For number 2, since we're talking about arc length, we're going to add in some new questions. So if you look at a clock, we want to find out what is the length of the edge of the clock if it goes from 12 o'clock, where it is right now, to 12:15. So that is this section of your clock. And we see that the radius is 10 inches long. So since in our clock that this is 15 minutes, we need to see how much out of 60 minutes does that take up. So we have to divide our minutes that we have divided by 60 minutes, and we get 0.25. Now, to figure out how many degrees that is in our circle, we need to multiply that by 360 degrees. So our clock takes up 90 degrees of our circle right there. Now realize this one's a little bit easier to notice because it is just a fourth of the circle, but sometimes it could be like 20 minutes, so you still need to go through this process to figure out what the degrees are. Now that we know the degrees, now we can set up our equation. So degrees over 360 times 2 pi r, and our radius is 10, and then we can multiply everything again together. So if we take 90 times our 2 times our 10, we get 1800 exactly, and then we still have our pi, divided by our 360, and then we're simplifying just this portion, and we get 5. So we get 5 pi is our exact, or our non-exact, if you want the actual length of it, would be 15.7, and that would be inches long. So this is the new part that we're going to talk about next, is we need to change our degree into a radian measure. A radian measure just means that we have a circle that has a radius of 1. So think of your circle, that the radius is always going to be a 1, and we just want our answer in terms of pi. So it's the length around the outside again in terms of pi. So if you notice, our equation is pretty much the exact same that we had before, except the part that we're missing is this r, and that's because the r part already is automatically going to be a 1. So we are finding the length around the edge, but we know that this radius of our circle is always going to be 1. So it's the same setup. So we have this chart down below that I want you to start filling out. These are kind of more of your more common angles that you're going to be dealing with. And in our circle, if you notice that 180 is only half of the circle, so all the way around the edge of the circle, so circumference of your circle should be 2 pi. And again, that's because the radius is 1. So the circumference all the way around the outside is 2 pi. But if we have half of this circle, think of that would be half of the circumference. So automatically this is going to be just pi. But if you want to double check, you can take your 180 divided by 360 times 2 pi, and you do end up with the pi. Okay, so then if we did 0 degrees, that would be if I don't move anywhere around the circle and I'm just staying right there, so I have 0, which again, if I take 0 divided by 360 times 2 pi, I get 0. All right, so 90, think of that's only a fourth of our circle. So if this is only pi, so 180 degrees is only pi, then what do you think this 90 degrees would take up? Well, it's going to be half that distance. So it's going to be half pi. So some of these things you can logically go through and fill out just based on the size of our circle and just knowing what we know about how many parts of the circle it is. Now again, if we want to look at this even further, so if this is 90, that means half of that would be my 45. So what's half of half? That would be 1/4. And if we did the same thing for 135, that would be 90 plus another 45. So that's this halfway mark right here. That's where 135 would be, and that would be halfway between our half of pi and our full pi. So think what's between half and 1 would be 3/4. And remember, if you can't remember, you can still do 135 divided by 360 times 2 pi. So we're still going to go fill out the other parts of your circle, and this 30, if you think of the 90 is right here, 30 and 60 is dividing up this piece into thirds. So you have to think of what's a third of 1/2, which is a little bit harder to think of. So let's go ahead and set up our equation. So we'd have 30 over 360 times 2 pi, and 30 times 2 is 60. So 60 divided by 360, if we reduce that, becomes 1/6, which makes sense. So if we take half pi and we multiply it by 1/3, because this is a third of the distance, that becomes 1/6. So 60 then is 2 of the 30, so it's 2/6, but that would end up being 1/3 when we reduce it. Or we can always still set it up, so 360 underneath times your 2 pi, and again, if you multiply that, you get 1/3. So I want you now to fill in the 120 degrees. If you set up your equation, you would have 120 over 360 times 2 pi, which would end up being 2/3 pi. But remember, if we're looking at our chart over here, if this is 90, we're dividing up this piece into thirds. So we have 4 pieces out of the 6 if we divide this all up evenly. So if I kind of divide these up in pink instead for the thirds, we are at this second marker right here, so that is 4 of the 6 pieces, so 4 out of 6 becomes 2/3. So I want you to do the next one as well. See if you can use the setup up here to predict what that's going to be without calculating anything. All right, so 150 then would be 1, 2, 3, 4, 5 pieces out of the 6 total for half of our circle, so this would be 5/6 pi. Or when you set it up, it would be 150 over 360 times our 2 pi. So the whole goal is so that if whatever degree you are given, that you can change it then into radian mode, or radian measure, and you can use the pattern like we were using already, or you can just calculate it yourself with our equation up here. Okay, so sometimes you might be given the radian measure, and if we want to figure out where that shows up in our circle, so how many degrees is that in our circle, we have to work backwards. So if this is our answer to our equation up here, then we need to fill in the parts we don't know. So we don't know the degree, we have the 360, and then we have the 2 and the pi. So we're solving for D. Now when we're solving, notice that our pi's are going to cancel out because we've got 1 on each side. So we've got 8 out of 9 equals, and on top here we're going to have 2D divided by 360. And if you want, you could cross multiply even right now. So 8 times 360 will equal 9 times 2D. So you've got 18 times D equals 2,880. If we divide both sides by the 18, we end up with D equals 160. So we would have 160 degrees is where that would show up in our circle. So if you're thinking of the actual circle itself, if here's 180 and here's 90, it would have to be somewhat around here. So it'd be this length is how much we had just found.